Assalamualaikum and good day. So now I will continue my lecture for chapter 6. Focus on subchapter 6.8 which cover generator protection. Okay, as we know, this is the outline for chapter 6.6. So now I will continue my lecture focus on the 6.8 chapter which cover generator protection. Okay, as we know, an AC generator protection system has two purposes. The first one is to protect the machine, and the second one is to protect the network. Okay, the main faults that may affect a generator overload, such as overload, and then we have external face-to-face short circuit, internal face-to-face short circuit, internal face-to-frame fault, rotor frame fault, loss in excitation. Okay, means that the loss in excitation means that the voltage running the generator is not stable. And then motor operation, under or over frequency. Next is voltage too high or too low. And last is loss of utility power supply. Okay, next we go to overload. Types of fault is overload fault. Okay, this is the setting of the overload fault. First one is the thermal overload protection. Okay, the maximum allowable heat rise or H set is equal to 115 to 120%. So the time constant is depends on the generator size specification. So this is the range of the thermal overload protection setting. Okay, then is temperature monitoring. Okay, the T set, the temperature setting is depends on thermal class of the generator. This we can see at generator specification. And the last one is the protection using a thermal magnetic strip relay to protect small generators, and the heat threshold is 1.2 IN, which same as the previous allowable percentage, which is up to 120%. Okay, next is the external face-to-face short circuit types. Okay, for this type, if generator with current held at 3 IN, IN is a nominal current for several seconds. Okay, and then the use of the protection is the independent time phase over current protection, and the threshold coherent or with downstream protection and less than 2.5 IN. So the setting is less than 2.5 IN. For the time delay selectivity with downstream protection. Okay, if the generator without current held at 3 times with IN, if we select the restraint voltage over current protection, the I setting is 1.2 IN. Okay, the time delay is depends on the selectivity with downstream protection. And if we are using protection using a thermal magnetic strip relay to protect small generator, so this is the IM that we have to set at the protection scheme. Next is the internal face-to-face short circuits. Okay, if high impedance differential protection, if you use this protection, and then I set is equal to 5 to 15 50% of IN. So there are no time delay, but we have to set the IN. And then if bias differential protection, the percentage characteristic is 77.5%, and the minimum threshold is up to 30% IN, and there are also no time delay. Okay, next is the internal face-to-frame short circuits. Okay, two frames mean that the from internal face to the body of the generator. Okay, neutral earth at neutral point of the generator stator. Okay, we have to use high impedance differential protection. The setting is 20% more than I nominal. So for overcurrent protection on neutral point earthing connection, the setting is 10% of IL. IL represent as the limiting current. Okay, and the time delay is depends on the selectivity with downstream protection. And if the fault is neutral earth in the network, so the protection that we have used is earth fault protection, and the setting is 10% more than IL. Then the time delay is 0.1 second. Okay, if we use residual overvoltage protection or permanent insulation monitor for disconnected generator from the network, we have to use the V RSD, okay, residual, which is equivalent to more than 30% from the V nominal, and then the time delay is several seconds. Okay, and then for condition of unearthed neutral, we have to use residual overvoltage protection, and the setting is 30% from more than Vn. Okay, and lastly is the rotor frame here. Injection of low frequency 2.5 Hz up to 20 Hz alternating current to monitor insulation, permanent insulation monitor. Okay, next is a loss in excitation. Okay, the protection used is protection against reversal in reactive power, and the Q set is equivalent to 0.3 SN, which is S nominal, represent as apparent power, and the time delay is several seconds. And for motor protection, the protection that we use is protection against reversals in active power, and P set is 1 up to 5% of the PN for turbine, and for diesel is 5 to 20% of PN for diesel, and the time delay is more than 1 second. And lastly is under or over frequency, and the frequency allow for frequency, the tolerance frequency that allow under and over frequency protection is plus minus 2 Hz, and the time delay is several seconds. Next, for the case of under voltage, okay, the protection is set to 0.75 up to 0.8 from UN, and the time delay depending on selectivity and network requirements. And for overvoltage, the protection is used to protect against overvoltage, and the setting is U set is equivalent to 1.1 UN with a time delay of approximately 1 second, and used to check the present of sufficient voltage, and U set is set to 0.95 UN with a time delay of approximately 3 seconds. And lastly is supplying active power to the utility loss in utility power supply. And the protection against reversals in active power is used, and the P set is set 1 to 2% of CERT3 NCT UNVT, which is NCT is current transformer rating, and UNVT is the voltage transformer rating. Okay, here is a stator spot protection. As we can see here from this figure or from this diagram, you can see here this is the generator. There are 3 winding here, red, yellow, blue. Okay, and then we have here is the line cities at the each phase, and here is the relay. Okay, and then the relay is connected between live and neutral city. This one is the neutral city, and here is the resistor, which is represent as the Rn. Okay, R represent as instantaneous overcurrent relay. Okay, this R is used to control the spot, the flow of the spot current. Okay, then from the diagram, previous diagram, we can have a formula maximum spot current, F maximum, is equal to 3 E phase. E is represented as voltage phase divided by Z1, Z2, Z3 is the impedance of the phase, each phase, plus 3 times with Z neutral for 3 phase. So for Z impedance of the phase is very small, so we have to neglect, and we have to divide 3 E phase divide by 3 Zn. So we cancel out the 3, and then we get the formula as E phase divided by Zn. So E phase is represented as the VLL divided by Z3. Okay, Zn represent as the Rn. So we can get the formula IF max is equal to VLL divided by Z3 square root 3 times with Rn. Then a spot current for the spot at P% of the winding from neutral end. So if we want to calculate what is the spot current for the spot at P%, okay, this one is the a spot happen at the P%. So we have calculate what is the I for at this percentage P%. So we have just to times this formula IF max with the percentage. So means that we just times the IF max with the P%. So P divided by 100% is the P%. So which is equal to Q times with PCT. Okay, Q is relay pickup in percentage, and PCT is the city primary rating. Okay, here is the example for 6.8. A 3.3 kV 3-phase 10 MVA star connected alternator is protected by an earth spot relay having pickup setting of 5%. Okay, the CT ratio is 1000 ratio 5, which is primary side is 1000 and the secondary side of the CT is 5 M. Okay, if the neutral resistor limits the maximum earth spot current to 25% of full load value, A, determine the value of the resistor and percentage of the winding protected, and B, the value of the resistor needed and the maximum spot current to allow only 5% of the winding to be left unprotected. Okay, here is the solution for A. First, we have to calculate what is the IFL full load for generator, which is S divided by square root 3 divided by V. Okay. Then we have to calculate what is the IF max. Okay, IF max, as we know, the formula is VLL divided by square root 3 divided by Rn. Okay, then we this value is equivalent to is limited to 25% of the full load. This is percentage is given in the questions. Okay, then we calculate what is the Rn value. Okay, Rn is equivalent to equal to 4.36 ohm. Okay, then we have to calculate what is the IF. Okay, for this Rn, so we can get this formula 3.3 times with P divided by square root 3 divided by 100 and divided by Rn. Okay, this formula, when we simplify its formula, we can get the formula is 4.37 pm. So we have to calculate what is the value of p, okay, which is equal to q divided by value of current at the primary side. Okay, so this one is q and this one is the value of the primary side. Okay, which is PCT, this one 1000. So then we can get we can use this formula which is equal to this, and we can calculate what is the value of P, which is equal to 11.44%. Okay, this P is the value of the unprotected winding. So in the questions, we need to calculate the protected winding. So we have to deduct 100% with the percentage of the unprotected winding. So which is equal to 88.56%. Okay, next is the solution for B. Okay, for only 5% of the winding unprotected. So for B, we have to calculate what is the resistor needed, Rn, and the maximum assault if the allow of the percentage is 5% of the winding to be left unprotected. As we know, for in A, we solve the P and we get the unprotected winding is about 11.88%. So for these questions, we just allow only 5% only for unprotected. So we have to calculate what is the new Rn for this condition. Okay, so by using the I4 formula, and then we have times with the P percent is only is allowed only 5%, so we have to put the value 5 divided by 100, okay, which is equal to 50 m is from the previous, if is from the questions, which is the pickup setting of the CT is only 5%, which is Q is 5%, and times with the PCT, okay, PCT is equal to 1000. Okay, that's why the value of 50, we can get the value of 50 m. Okay, from the 0.05 times with the 1000. So, which is equal to 50 m. So, when we solve this formula, and then we get the value of Rn, which is 1.91 ohm. Then we have to calculate what is the I4 maximum. Okay, by insert the new Rn with 1.91 ohm. Okay, we can get the I4 IF max 997.5 m. Okay, as we know, this current is much higher than the case in A, and when the current flow to the ground is more higher, so that the winding of unprotected must be less. Okay, so this is the current of the generator that will be flow to the ground if fault happen. That's all for chapter 6. Okay, thank you all. Assalamualaikum.